Yeah, so we're third time's a charm. We were talking for about 20 minutes and realized we didn't hit record. And then as soon as we started recording, my power blipped and Wi-Fi router went out. So we're trying again. But welcome to another episode of Energy Bites. I'm Bobby Nealon. We've got John Calfan with us. We've got the Axis Energy Services rocking.
Shout out to Santo. Appreciate the swag, man.
And really excited. We've got Jacob Matson with us. He's the developer advocate from MotherDuck. And super excited to have you on. We've gone back and forth on social media, various platforms for the last couple of years, and excited to have you on.
Yeah, I'm excited to be here. Get to talk about the cool things we're doing with DuctDB and at MotherDuck. So yeah, I'm really excited to talk about that, but also talk with people who are in the domain and not just thinking about software, but like doing real stuff with it, which is like one of my favorite things to do. So love it.
No, absolutely. And
real quick,
again,
Bobby,
what's up?
Because we're gonna be talking at some point about data and analytics. I was actually looking at our channel analytics, and 75% of you watching this are not subscribed. So please go subscribe really quickly. It takes 2 seconds. We'd appreciate it. It's somewhere over here.
Yeah. And as most people who've been listening consistently know, I try to find someone to talk about DuctDB. And this time I was like, I'm going to just, make sure it happens. I'm going to talk to, one of the guys that works at MotherDuck, probably one of the main, companies that's the main maintainers of DuctDB. And I know Jacob's been using it for some pretty cool use cases over the last couple of years. So really excited to dive into it. Because again, I think there's a ton of opportunity in the oil and gas and energy space to use it. I mean, probably any industry, but especially there where we have, applications all the way from IoT all the way up to the cloud. So, I think it's super powerful. And, kind of want to lead off looking at a somewhat, current event. It was about a week or so ago. They came out with DuctDB for Google Sheets, DuctDB-G Sheets, I think is what it's called. Mm-hmm. But basically it allows you to read from and write to Google Sheets using pure SQL. Yeah. Really kind of opens up a lot of doors for people that maybe they only had if they used BigQuery or,
Yeah, totally. Yeah, we're really excited about it. That actually came from the community. One of the guys over at this BI company called Evidence, Archie built that. I think it was one of those things where it's like, oh, this takes too long. Instead of it taking, this took too long. Instead of it being, an hour, now he's going to spend 100 hours, writing code to fix the problem.
But it helps everyone else, right?
Yeah. But yeah, what it does that's really cool is it kind of opens the doors around a lot of kind of flows where you can take data out of Google Sheets, handles authentication kind of seamlessly, and then push data back in. And so if you think about John, on our first recording, you mentioned, hey, this is kind of like Power Query, but for Google Sheets. And it's like, yes, exactly.
You get to let the end users have the data where they want it and not allow them access to the database to screw things up. So it's a beautiful world, right?
Yeah, totally. And I think it's also, it's really nice to be able to get like access to these database primitives on top of Google Sheets and, kind of do a lot of fun things that maybe you wouldn't be able to do in the past or without, authorization. And now you can just kind of do it. And it's very cool.
Yeah. Well, that's the thing, right? Like Google has this whole ecosystem, and most people aren't familiar with it, at least on the enterprise side, because most of them are Microsoft shops, and so they have no need for it. But like our company is a Google shop. All of our stuff is on Google and Gmail and all that stuff, and it's just incredibly powerful how much kind of interoperability and connectivity that the G Suite platform offers, right? Being able to pass things from Drive to or docs to Sheets back and then into Forms and basically every direction in between. And so something like this is really, really slick, where you can pull from your database right to, an end user's kind of notebook or worksheet and let them do whatever they want to do from there. And then you can layer app scripts on top of that and do all kinds of other really interesting things as well. So it's really cool. I just love Google Sheets and all of that stuff for like POCs and stuff. It's such a quick and easy platform, and all the language models know how to write an app script, and it's fun.
Yep, totally.
Well, and John, I didn't think about the first time but this could actually play really well with what probably one of our first 5 episodes, we had Jeff Davies on, and he's got Rapify, which is basically a way to like, I think he pulls the data out of or into the Google Sheets, and then serves it out and basically creates like ready to use like investor presentation type things out of it, or it ties into the Google presentations layer, and then but creates the charts and everything from it. So
really cool.
It can actually be pretty interesting to layer into that process too. So yeah, why don't you tell us, Jacob, about your journey into just data in general, and then like how it kind of got you to this point.
Yeah, sure. So if we go back in time a little bit, I actually have a degree in accounting and computer science. I started my career actually more on the accounting side. And as it turns out, there's a lot of shared primitives. If you zoom out a little bit, a lot of analytics is kind of just like stuff on top of ledgers, as it turns out. That's also like my own bias. Like, oh, this is just a ledger. Cool. Like, what's a snapshot? That's a ledger. Cool.
Yeah. Even just like, so you're even getting like slowly changing dimensions and stuff, right?
Yeah, totally. Like, it's all the same. I'm like, oh yeah, I know what that is. Like, yeah, cool. Yeah, definitely you can apply a lot of the same principles to it. And what really happened is that like, I kind of realized pretty early on that I'm pretty good at kind of persisting around a problem probably longer than I should. And so what that means is you kind of just naturally drift into harder and harder problems. And eventually I got to the point where, Excel was not enough. This is probably maybe 5 years into my career. And I says, okay, well, we're running our ERP system on premise. It's Microsoft Dynamics Nav. It's got SQL Server behind the scenes. How do I get access to that system so that I can start doing analysis directly on that? And so that was that was the start of the journey, kind of into the data side. Just over time, just got more and more in depth with SQL Server, honestly. In fact, I'm actually running it on my MacBook right now, in a Docker container, which is hilarious. I found out yesterday that the Linux, it's running Linux inside the Docker container, like Linux version of SQL Server, and the syntax is slightly different than Windows SQL Server. Yes, slightly. So it's like, well, okay.
These are the things that I love about coding. It's like, oh yeah, syntax matters. Capitals and space, like that's.
Well, and also going back and forth between dialects too. I mean, like, if it's case sensitive or not. I mean, like that. I've beat my head against the wall with Snowflake because I didn't realize that it was case sensitive. For like an in clause. I'm like, why is it not finding this? It's right
sure.
there.
Like, for text. Yeah, absolutely. Like the collation types in SQL Server for sure. It's like if someone didn't install it right the first time, well, now you have a case sensitive SQL Server, and like everything else in the Microsoft stack is case insensitive. I don't know if you guys.
I ran into that with a hot tip for people in oil and gas. Like it was there's a software called Open Wells. And I think they may have made like, it was like either one table or one column case sensitive, but everything else wasn't, because it was this ID column and the ID was repeated as far as in the thing, but it was different capitalization, but the actual characters were exactly the same. So it was fine in Snowflake, but then Power BI was choking on it because it said that it had duplicate.
Yeah, Power BI is case insensitive by default on joins. Yeah. That's right. Yeah.
So that was an interesting one to
I mean, I kind of want to make it a mission in my life now that I'm just going to make a library that gets rid of all of these things when you code and you talk between these things, because it's so frustrating. The code is there and it should work and it doesn't, and it's because that's what turned me off to coding when I was in like high school.
Oh yeah, for sure. I remember kind of being early in my career and dealing with Salesforce data, and the opportunity ID, for those of you who don't know, is a case sensitive 15-digit ID, I believe. And basically, if you do a VLOOKUP on it, you can get the wrong data back. And I learned that by putting data into a board presentation that was incorrect. Yeah, it's very good.
Always
feedback
the
loop.
Hardest way.
Yes, learn that lesson. But so basically, as it turns out, a lot of the kind of accounting principles have applied usefully to databases, and eventually got to the point where the type of operations I was doing were too slow, kind of in a transactional database. And so around that time, I started exploring what other options were and discovered DuctDB, which is an embeddable kind of in-process database, and kind of works seamlessly on all types of data, including CSVs and Excel, and Parquet, et cetera. And so that was really kind of my door into even faster analytical queries using kind of an open source MIT licensed library, which is DuctDB.
Nice.
And just I'll do a quick aside on that real quickly, Bobby. So from a maintenance standpoint of DuctDB, there's actually the kind of the owners of it is the DuctDB Foundation, and it's maintained by DuctDB Labs.
Okay.
And so they're on point. We have a relationship with them, in terms of getting stuff updated for us and maintained for us on the MotherDuck side. But they are independent. It's kind of governed one way, and I'm only calling that out because it's important to understand the difference between the two and how we fit. So yeah.
No, absolutely. In our previous recording, or not unrecording, you kind of dove a little bit into
don't know what you're talking
about. OLTP versus OLAP,
sure,
transactional versus analytical processing, and just if you touch on that real quickly, just
sure,
for people who may not understand.
I mean, I think basically there's just different architectures for these databases, and you can kind of broadly put them into two buckets. There's the OLTP, which is online transactional processing, which are databases designed to kind of have high throughput on transactions. And a transaction you can think about just as a row in a table. So they're built with certain trade-offs in mind. And really what that means is when you're accessing the data, you're accessing it, kind of in row at a time. And from a analytics perspective, we, again, it's online analytical processing engine. For those, we kind of we store columns or data as columns instead of rows. So we access it and aggregate columns, et cetera, slice and dice dimensions, et cetera. And so it just thinks about things differently in terms of how it interacts with, kind of low level hardware and software. And so what that means is something like an aggregation operation in an analytical database is much faster than in a row level database or like a transactional database, broadly because we can just look at a single column versus looking at all the rows in order to get a single column. And that's a massive oversimplification. And there's a whole bunch of different trade-offs that a bunch of different databases make. SQL Server and makes different trade-offs than Postgres, than Oracle, et cetera. So I want to just be careful there.
Yeah. I'm sure they'll tell you about it. They'll tell you about it in the comments. If you want to tell Jacob where he's wrong, go drop them in the comments below, guys. That'll be fun.
So that's kind of the core difference. I think there's one more thing that's really interesting that is specific to DuctDB that I'll share, which is DuctDB kind of came of age in the era of multi-core processors, which is different than more mature databases in the analytical space, like a Snowflake or Databricks, et cetera, which are kind of designed to scale out across multiple nodes. And so part of the reason why DuctDB is so fast is it's designed to be super fast on a single node, and it has vectorization and really advanced query planning built out around the fact that my laptop I'm running this on has 14 cores, right? So I've got all this compute available to me, and I can just break my query up into a bunch of chunks and run it in parallel. And so that's kind of the some of the core innovation that they bring, and they bring all that power to the fact that you can run it locally. More or less kind of as a library, which is really cool.
Nice. And I didn't think about this earlier, but can it also tap into GPU at all, or is that anything that's kind of outside of its scope now?
So right now it's outside of the scope. I'm sure someone's thinking about it. I know that there's lots of interesting engines that are doing that. There was one that kind of an open source one that was taken on. I think it's like BlazeDB. It's not maintained anymore. I think it maybe got acquired by Voltron, perhaps.
Okay.
But there's a company, Voltron Data, who's doing a bunch of GPU stuff. It's not there, but as it turns out, we have so many cores that we'll see if it's necessary, at least for these kind of relational algebra problems.
I think some of the interesting stuff from our prior conversations was being able to run it literally anywhere, even in browser. And then what is really interesting to me is the querying URLs and basically being able to ingest JSONs directly. That's pretty wild. Like, that's really slick.
Yeah. So one thing that's really cool about DuctDB is it does have excellent native JSON handling. So the first thing it can do, that means you can use this read JSON function to read a
like
JSON
an API
file
response,
either locally,
right?
or an API, or an API response if it's a public API. You can just hit it and load it straight into your database, and it'll do like one level of like transformation unnesting kind of when it does that. There's more complex controls you can implement too to like do your full unnesting all in SQL, which is really nice. And then recently they added the ability to pass authentication headers with a JSON with these calls, which means you can basically do a get API call like you could with a curl, for example, and just do that all in SQL and get a response back, which is really awesome because it means you can kind of take these abstractions that used to require or these interfaces, that used to require kind of lower levels of abstraction and just move it all into SQL.
Yeah.
So yeah, some really, really cool stuff there. I've done a few. So I'm a big sports fan. I actually run a project called MDSinaBox, which has an NBA kind of ELO model that updates every night based on real results to kind of keep the team it does team level forecasting for games and things. And
we need to talk because I got into the data side for fantasy football, and so I'm right there with you on the football side.
So there's a football model too, actually, but I have to update that one manually. I never got the API set up, but I should. But yeah, there's a bunch of really cool stuff that you can kind of do. It's pure SQL. I did used to kind of have a little stored procedure thing in there that I replaced with Python. So I guess it's no longer pure SQL, but all open source, that entire project. So you can check it out, MDSinabox.com. It does use DuctDB and DBT and a few other of those kind of like modern data stack so-called pieces, just to solve, a problem that was tickling my brain. And so hopefully you can enjoy it too. Yeah.
And am I right? You're running a Monte Carlo simulation inside of SQL?
Yeah, so it's actually, it runs in two ways. So yes, there's a Monte Carlo simulation that's kind of at the core of that, right? Because we can basically say, hey, the probability that team A will beat team B, if we can express that, then we can just roll a bunch of dice and say, okay, for 10,000 scenarios, what does it look like if we combine all of these, an entire schedule of 1,000 games, right? And so, yes, there's Monte Carlo there. There's also another page, and this ties in nicely to kind of running DuctDB everywhere. There's also a WASM library, which is a WebAssembly, and it runs entirely in the web. And so there's actually a page on there that you can compare any team from any era in the NBA.
That's cool.
Right now, it has 86 Celtics versus 96 Bulls is kind of the default. And what it does is it runs a 7-game simulation and says, okay, so if these teams played each other 7 times and we run that scenario 10,000 times, which is with Monte Carlo, says, hey, what percentage of the time would, the Bulls win versus the Celtics win? And, what percentage of the time would it be a 4-game series or a 5-game or 6-game or 7-game, and who wins and all that kind of stuff. And so, and that's all in the browser. What's really cool is actually if you take a look at that page and you can change the parameters, maybe choose a different team in the drop down. I'm a big Sonics fan, rest in peace. They don't exist anymore. But you can check hey, like those Gary Payton, Sean Kemp Sonics, like compare, like how do they stack up against, the Celtics or whatever. And you can just kind of change the drop down and it's like instant, like it just calculates. It's crazy how fast it is. And that's, WASM is just one core. And so, once you can kind of get all your cores, it's even faster. It's honestly mind blowing. The things you can do kind of with this little library with database primitives.
Yeah,
that's pretty amazing.
NBA Jam flashbacks.
Oh yeah, for sure. Yeah. For
Gary
sure.
Payton and Sean Kemp. Yeah.
Detlef Shrimp was on that team.
Oh yeah. Detlef Shrimp. Yeah. Actually, I haven't. Those like 1-Up arcade cabs. I have one down in my basement. I have an NBA Jam cab down there.
So nice. Yeah. Yeah. Nice. I had the Sean Kemp shoes too. The ones with almost look like mountain range on it.
Oh yeah. That's sick. That's great.
Back in the day. But is actually, that brings me back. My daughter now, like her feet are just growing at an insane rate. That was probably, I think I was about third grade as well, but like she's like in a woman's 8.5 now
Wow.
in third grade. But I remember just blowing through shoes, and I think the Sean Kemp's were one of those that I just wore for about 3 months, and mom, they don't fit anymore.
I was gonna say, begged your mom to buy, and
yeah. It's funny.
So all right, so we're getting into like, I mean, actually, you brought up MDSinaBox, so let's talk about that.
Sure.
Because we can talk about, we've brought it up a little bit with the modern data stack, but I mean, this is like an end-to-end data pipeline and visualization, all in one container, essentially, right? You can container,
That's right.
This is containerized, you can run it, on your own, PC or server or whatever. And I think that's a just super interesting concept, even just say if I was doing consulting or something like that, where if I had an oil and gas, database in a box, kind of thing, almost like where like, this is something people could think about, and you could package it and basically, if it's containerized, run it anywhere, right? And because you have all the way through, because you brought up evidence. Sorry, John. Evidence is one of the visualization options you have in MDSinaBox, isn't it?
Sure. Yeah, it's the core one right now. It used to have Superset in there too. But Superset ended up being a little bit heavy for kind of like an embedded solution. So ended up kind of going away from it, but great tool as well.
Yeah. So, and we're using, I know you had DBT, but as far as the ingestion, is it Meltano, or how do they say that? Or
yeah. So there was some Meltano stuff in there at one point. That's kind of been removed. I'm using a simple script from DLT Hub now, which is a Python-based replication library. Highly recommend it. Has a great SQL Server source, by the way. Very fast to get data out of there and into wherever you're trying to get it into.
If anyone hires me, again, I get to build something greenfield, and something better hasn't come out, like I'll do that instead of Fivetran. Sorry, Fivetran peeps, but
look, Fivetran's a partner with MotherDuck. Like we love what they do. The simplicity and the abstraction layer they have is excellent, but sometimes you need a little bit more, or if you're cost constrained, it can be a little hard to do that, or maybe you're running something out in the field, right, where it's like you're not connected to the cloud. Sure. What can you use in that case? And the MDSinaBox primitives, because it's open source. Like I kind of built it with the idea that like, you can kind of stick that thing anywhere. I think this is actually a nice segue into what I was doing before. I was at MotherDuck. I was actually running the finance and ops team at a IoT data platform called Symmetric. And so we were sitting on top of like the carrier networks and ingesting a bunch of data, for customers, and then repackaging it and then giving them, automation rules and things that they could do to actually make changes to their deployment back in the on the carrier side. So in some ways, like MDSinaBox is just like a stripped down, version that inspired kind of by that type of work, which is like a lot of the times when you're building a data platform, you're kind of thinking about segmenting it by customer or by, types of devices or whatever. And so we can take these problems that look really big and intractable, and if we segment them down or partition them small enough, now it's like, oh, we can actually fit that whole thing on like a Mac Mini, right, or whatever, which is crazy. Yeah.
Well, yeah, and I think thing for us, John and I, we have experience with it, and we bring it up quite a bit. But you say in oil and gas, like a frac van or even like a drilling rig, and these are remote locations, but like the cloud is great, but if you lose that internet connection, like you have critical operations that, if you're utilizing, that software ever for critical reasons, that you might have shut down operations. But something like this, if you're able to, you can run it on the edge or on-prem or in the cloud, and then you can, have that same functionality, locally that you have in the cloud. I mean, now it becomes even more powerful, rather.
Yeah, totally. I think that there's some actually really interesting stuff that this guy Brian Chambers at Chick-fil-A has written about kind of hybrid cloud stuff, where they actually have in every Chick-fil-A like 3 little mini PCs.
Nukes. Yep. They've got Kubernetes clusters.
Yeah, I think it's K3S, but okay, so you guys are familiar. But like those things are designed to they predict, hey, here's how many fries you need to put in based on how long the line is in the drive-through or whatever. And they work, if the internet's down, and all they're really doing is kind of sending aggregate data back to the cloud to kind of improve the statistical models and things. And
I think that's POS is even on it to some extent, because like in Houston, we have hurricanes and the power goes out when the hurricanes come, and there are very few places. I worked for a edge startup before I came to DW, and so some of these like people in our industry aren't thinking of the edge as robustly as I think they should be, where it's like Chick-fil-A, right? Like I would love to have Chick-fil-A on the pod, by the way, if they are listening, but they like they're doing a masterclass in it though. Like it really is fascinating. I mean, they were already an operational savant, to begin with, and then they're layering this tech on, and you think like, I ordered Chick-fil-A for lunch on my phone yesterday. It started like you put in the type of vehicle and the color, and now you've got the cameras outside that can see there's a gray truck in line, and a guy with a gray truck just ordered food. So make sure it's ready. Like they're doing a lot of really cool stuff that I don't think a lot of people outside of the direct tech community are even like aware of.
Yeah, but I mean their stuff is crazy. Yeah,
but isn't that kind of like how we've said, even just about AI now too? But like if you're doing a good job with it, people shouldn't even know you have it in the platform. You should just make the user experience better.
Yeah.
So
that's right. That's right.
And like even just like whether it's if you're designing a web page, people don't care if you use Angular or React or JavaScript. Did it work? Did the button do what I wanted it to do, and was it fast? And the same thing I think applies across all different spectrums of like just make the user experience better, and that's what it's all about.
Yeah,
totally. And make it maintainable.
Yeah. Totally. I think and I think you hit on something really interesting there that we've seen with DuctDB too, on the MotherDuck side, which is like, because it takes all these really nice abstractions and brings them to pure SQL, it's kind of maintainable and iteratable across, it doesn't matter if it's a business user or a data analyst or a data scientist or a data engineer or even a software engineer. The primitives are kind of understood across those groups. And so what that means is that if you have a hard business problem, like getting people around the table and speaking the same language is like now becomes a much simpler problem. It's not like, oh, this team uses this team uses this team uses this. It's like, no, we're all kind of jamming on SQL, and by doing that, it really means that the things that really matter to our business we can get at faster. And I think that's a really cool thing. And obviously with one advantage of SQL today too is that like there's 50 years of training data in every large language model, right? As much as like there's things that are kind of crappy about SQL, right? It's like written in the wrong order. The query plans are not deterministic. Like, if you're not using DuctDB, it's slow. You have to like install a really heavy server on a somewhere and then access it from a client, et cetera. Like all those things, are kind of pretty bad trade-offs. It's very verbose as well. But, with DuctDB, it's less verbose, it's faster, there's libraries, all these things that like traditionally are challenging with SQL become less of a problem. And in fact, about 23% of users that use DuctDB identify as software engineers. So it's not just, data people using it,
right?
Which is excellent. I think it might be the first time that I've heard a software engineer not hate SQL using DuctDB.
That is like the tagline right there.
Yeah.
Like genuinely, right? Like,
because I know, John, we were talking to someone recently, but I mean, just about how they're actually, or maybe it was someone else, but how you would assume that a lot of software engineers know SQL, but it's really not the case because of ORMs and everything. Like, so they end up having it being written by the ORM, and they never ever have to actually go write SQL on their database.
Yeah, totally. I mean, that tracks with my experience. I think, and a lot of it too is like query optimization, which is something for those of you that are on SQL Server, you probably are very good at. Just it's a more constrained environment, and it's like I've definitely seen a lot of SQL written by software engineers where I'm just like, oh, well, let me add some temp tables there. Let me fix a couple things here. And now it takes like, a second to run. And it's like, there's like, why do I need to know how this thing thinks about it? Like, why doesn't it just execute the thing I wrote? And it's like, well, there's really good reasons for that, but also totally understood. Like the thing that I would say about DuctDB is it's the first time that I've seen repeatedly where the query planner is good enough that they're like, okay, this is fast enough that I don't care. I'll actually write SQL because it's fast enough. and I don't want to, an ORM actually is going to make it slower. And so I think there's some really interesting things that are kind of happening with that that are only possible with like really great library like DuctDB.
Well, I think the other point there is, and I feel like I've kind of learned this in my product manager journey as I've across, we've built software across a bunch of different languages and stuff, but I don't think enough people appreciate like, yeah, SQL's been around forever and like it's robust, there's all this documentation, but from a maintenance longevity perspective, it is infinitely easier to go find someone to hire that knows SQL than, Rust or some, I know those aren't direct comparisons, but
sure.
Right, like the new shiny sexy thing is what people always chase. And it's like, but then you go start building, you're like, well, shit, I can't hire anybody because there's only 50 Rust experts in the world or whatever.
Or you can, but you can't afford them.
Right, exactly. Yeah. That's my point, right? Is it's like there's a lot of value that just like secondary, tertiary value in using these very robust, well-known languages across, as many places as you can, just because of the longevity perspective, the maintenance perspective, right? Like Bobby and I, we always, I'm sure it's similar in other industries, but it's always the build versus buy question.
Oh yeah.
Should we build it ourselves? Well, if we build ourselves, how are we going to maintain it? Blah, blah, blah. Well, if it's SQL, that's a pretty easy thing to let, to find people to maintain for you instead of some new, abstract thing.
Totally.
So, and I think we hadn't necessarily got too far into it here. Like, I'm trying to remember what we did the first time versus, now that we're on here, but when we talked about just being able to like kind of query the data where it lives.
Oh, sure.
I think was talking about how, I think for a while there, so I was working on a little project that died on the vine because I didn't have time for it, but and I'm not sure if you're familiar with Immaculate Grid or not.
Mm-hmm.
It's like a 3x3 game. So me and a couple buddies, shout out to Jeremy Funk and Brian Becker, friends of the show. We had a little text group where we'd share our results, kind of like Wordle for people who don't understand. But I'm trying to come up with like a Immaculate Grid solver, kind of thing. And then was trying to use Duct. I wanted to play with some technologies that I hadn't had a chance to play with at work. So could I use LLMs to help write the queries, but use DuctDB to query the data in place. And I found like the Lawman data set would be one I could use to probably answer most of the questions. So I was working on, but I think what I'm getting to is the fact that you can query like a URL. Like I can say, select these columns from, GitHub blah, 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 / fielders.csv, and it'll pull up all of them, and it'll filter them and do all that stuff. And I never have to move that CSV onto my machine or anything. It just queries it in place. And it's super fast. And it's just, I think you said the first time you do stuff like that, you can't believe that it actually works.
You have to run the query twice. I've heard that from multiple people where it's like, you run the query the first time, like, wait, hang on. Like, why did that take 500 milliseconds? Like, I know databases, that query doesn't take that long. Like, then you run it again, you're like, what? Yeah, totally. It's super interesting. And like one thing that's interesting too, like in terms of querying data at rest. So like CSVs in general are pretty large, like they're not very well compressed. And so one thing that we can do like with DuctDB that is relevant, like to think about like the IoT space is, you can do a select star from a CSV and it'll keep the data in the CSV. But you can also do just like a create table as, and it'll take that data and pull it in and save it in the DuctDB format. And that DuctDB format is roughly 5 times more compressed than Parquet. Wow. And Parquet is probably 5 to 10 times more compressed than a CSV. And so what that means is if you're going DuctDB to DuctDB or DuctDB to MotherDuck, and maybe you're in a bandwidth constrained environment, it's very easy for you to write a small amount of data across up to the cloud in a way that understands the constraints of your environment, right? And so I think there's some interesting stuff there where you can do a bunch of analysis kind of on maybe a big data set generated on a bunch of sensors out in the field, and then either get all the raw data up to the cloud, or you can do aggregate and compress kind of at the source and then send up kind of in a database tabular format in the DuctDB format up into the cloud. And I think we've seen some really interesting stuff there too. And it runs, it's well enough too. I think like there's I've seen people, I think they might do this at the Chick-fil-A scenario too, where it's like if the network's not available, it just keeps a little database running, and then once it's available, it jams everything up to the cloud.
Kind of like MQTT.
Correct. Yeah. So there's some interesting scenarios there too, where it's like, because in order to write really fast querying, you actually really care about compression, because you want to get as much data as you can in your RAM and into your CPU, right? And those buses are not very big, and so the better your compression is, the faster your queries can run. And so it becomes like this really virtuous cycle of, hey, the better compression is, the faster we can run queries. So let's figure out how to make compression better. And so they've implemented a bunch of cool tricks that we take advantage of in MotherDuck too, to kind of just make these things super fast.
It's just like Silicon Valley with Pied Piper, right?
Yeah. Yeah, for sure. It's definitely a virtuous loop, and it unlocks a bunch of stuff if you can figure out compression. And yeah, they yes.
That brings up something I want to hit on too, because when we start talking about passing data around, so I think one thing that's going to be very interesting the next year, 2, 3, 4, 5 is hopefully a shift from ODBC to ADBC, or the Arrow database stuff. Mm-hmm. And just can you expand on that? I mean, I can talk high level about it, but I mean, if I imagine you're a little more in the weeds on it from your side of the world, but
yeah, sure. So that's kind of that actually aligns really nicely to what we talked about earlier about OLTP versus OLAP in terms of rows versus columns. So the cleanest way I've thought about ODBC, which is kind of the traditional way to access data, is that's row based.
JDBC is similar too, right?
Yeah, JDBC also I think is row based too.
Yeah, I believe so.
I don't know if that's exclusively true.
Yeah, I got Google, but nonetheless, I mean, ODBC versus ADBC, I think is the bigger one.
ADBC, is based on Arrow, which is very performant kind of file format, and it's columnar. So what that means is you can kind of push down your kind of query a little bit down into your source layer, and only get the data you need. Whereas on a row-based data set, if you're doing aggregates, you have to get all the rows. And so there's more to it than that. Again, like I'm generalizing maybe a little bit too much, but there's some really cool stuff that you can do with ADBC, and as it's seeing broader adoption. I'd love to see an ADBC Excel connector. Have not yet seen it, but someday.
Because isn't that something? Because when people have run DuctDB even within Power Query, you could technically do it, right? Or something along those lines, or yeah.
I'll talk about this briefly. So DuctDB is just single binary, and so you can kind of install it almost anywhere, like Linux, Mac, PC, in a VM, inside Python. So like you can just do pip install DuctDB, and you have a full database running inside of Python. I think it's like
that's crazy.
20
that's awesome.
20 megabyte executable or something. It's not very big. And so what that means, though, is I believe Power BI, for example, can execute arbitrary Python in Power Query in the Power BI service. And so you can build like a Python script that is, has DuctDB, and therefore you can then use all the DuctDB primitives to pass pass data as a data frame back into Power BI.
That's interesting, right? So like that's I got into Power BI because of fantasy football, of course. Sure. And one of the annoying things about Power BI, if you're, a citizen coder, is I don't want to go set up a fucking database every time I want to go query fantasy football stats. And so it's like, so you can call the APIs from Power BI, but then you've got to loop through, pagination and nesting and all the fun stuff is not great to do in Power BI. So something like this, I could just spin it up in a Python script into a database. That's pretty slick. Yeah, and then I'd never have to mess with it again.
Yeah, you can even do like a pre-processing step where you just like rip your data down into like a Parquet file or CSV or whatever. Because like actually the Power Query and Excel CSV reader is excellent, right? It's literally best in class. Like it is so fast. The DuctDB one is also very fast, but they benchmark very favorably against each other. So yeah, you can do all your pre-processing kind of in a Python script. One thing I was talking about earlier, like, LLMs are great at SQL. They're also great at Python. So like if you can kind of think a little bit about how a computer works and reverse engineer what you're trying to do, you can kind of express that as a prompt and then, get 90% of the way there really rapidly. It hallucinates a little bit here and there. You still need to, I think one thing that's been really beneficial for me as someone who's coming from an accounting background is like, I'm just like, oh, well, obviously I can use this code that's generated from an LLM, but the thing I really need to do is make sure that my tests pass, right? Which it's just auditing. It's just auditing data. Mm-hmm. I was like, okay, great. Let's write some tests. If it passed the test, it's great. We can use it. If it doesn't pass the test, we can't use it. And so that's been very helpful, especially because then you can like write those assertions as, in your prompt and say, okay, make sure it passed this test or whatever. That framing has been very beneficial for me for sure.
That's a good tip right there.
There you go.
Including the tests with the prompt, right? Like I use LLMs all the time. I use it to code Python explicitly almost. And, there's still lots of people that are like, these things suck. They're not going to do blah, blah, blah. And I'm just like, you're not giving it enough context. I mean, so like giving your tests, that's another really good one, right? Like I tell people to give it the documentation, pass it the GitHub repo.
Yep.
There's another one that I just saw where you append the G on the GitHub to something else, and it makes the entire Git into a plain text that you can pass into a language model.
Oh, really? That's interesting.
And I'm like, that's really slick. But anyway, the crazy thing that I think is, I don't even necessarily need Power BI because I can just put in the API into the query, and it can pull it directly, parse the JSON, return directly into the database. And then I can just use Python for the visualization, right? Like,
yeah, totally. I mean, that's exactly right. And I think like one of the cool things about it is about DuctDB specifically is like, if you can install a Python package, you can install DuctDB, right? Like it gives you all the database stuff without having like, gatekeepers in the way. And so, and you're not like, because it runs all locally, it's like if you mess something up, like it's just your computer, you're not like deleting records from like a production database, and so like, it's a really great way to actually like learn and pressure test and all these things that are like really big blockers, especially like as you work your way up the stack, get closer to the product. And it's like, okay, well, like, how do you know these things, especially, for production, like ERP type, planning systems. We need more people who can write and read SQL, in my opinion, and it's a great pathway in there too.
So we kind of get onto the AI thing, and I want to get into that. And you tell me which one you want to tackle first, because some of the segues a little more because it's more specific to MotherDuck, I think.
Sure.
So I don't know if you want to talk about what MotherDuck or who you all are and how you fit in that DuctDB ecosystem, but then we can jump into all the different, kind of value adds there. But again, you guys have a few things. I mean, you've got, what was it, almost exactly a month ago, came out with the prompt function.
Yeah.
And then also just, text to SQL, any of that stuff that, is available there. So
Yeah. All right. I'll talk about a couple of things there. So what we're doing at MotherDuck is we're building a cloud service on top of DuctDB that is effectively a data warehouse. And so we are strong believers that most data can be processed on a single node, and that single nodes are only getting bigger. And what I mean by that is just a single computer, right? Even in the cloud. Here's a quick quiz. How big do you guys think the biggest instance you can get on AWS is in terms of number of cores and number of terabytes of RAM?
I'll let you take that one, Bobby.
I've never even tried to go that far because I think if I would be afraid if I even clicked on it, that would try
he looked at it, so we're gonna go ahead and click on it.
Yeah.
I don't know how Azure stacks up or GC Google Cloud, but the biggest node on AWS is 32 terabytes of RAM and 896 vCPUs.
Holy shit.
Now, I think those are built specifically to support SAP HANA. So
sounds right.
So like I don't think you can just like buy them and then like run DuctDB on them, for example. By the way, DuctDB doesn't quite scale out to that number of cores yet. Really its sweet spot is like 32, 64 cores, somewhere around there. So, but like that's the type of those there's huge nodes available. They're only going to get bigger. We can fit huge data problems into these things. And even a relatively smaller node, with like 128 CPUs and 1.5 terabytes of RAM, fits very nicely kind of in the notion of like where we really see kind of the sweet spot of where it fits in. And so, so we're building a cloud service on top of that. We have like our own little UI. It's very simple to use with the DuctDB command line. So DuctDB has a binary installer. You can put it anywhere. Mac, PC, Linux. Can't put it on Alpine Linux yet. Hopefully soon. Anyways, so you can install it, on your local machine, and then you just type in DuctDB and then MD : in your command line, and now you're connected to MotherDuck, and you can run queries, both locally and in the cloud. And what's really cool about that is we have this notion of what's called dual execution. So I can take data that's maybe in MotherDuck in the cloud, and I can either bring it locally, so I can do like a create table as select, and move that into my local database, and now it's free for me to query from there. It doesn't cost me anything because I'm using my local compute. And then what that also means is I can do something like take a CSV that's maybe some local data and then join it with data that's in the cloud very, very easily. So like, I don't know, maybe like I like to think about like a marketing thing here. Like someone gives me like an email list. I'm like, okay, I got a list of like 2,000 emails from some conference, right? And I have a HubSpot or a Salesforce account with a bunch of emails in it. Okay, well, like which ones are new? Okay, like there's a bunch of data
yesterday.
Yeah, you got to do a bunch of stuff to like clean it up, make it all match right, and then you can join them together. So that's something that you can just do all in pure SQL. The entity resolution kind of stuff or functions that are available in DuctDB are excellent. They're super fast. So that's kind of what we're building at MotherDuck is this kind of dual execution database that extends into the cloud and can run queries both locally and then in the cloud. And just as a technical example of that, I do a bunch of testing with the TPC DS data set, which is and I use that scale factor 100. So that means it's about it's a few billion rows and it's about 40 gigabytes of Parquet files. And so to kind of run the full suite on my laptop, which is like 32 gigabytes of RAM, it takes about 25 minutes. To run that in MotherDuck, it's about 5 minutes. So so a lot of that is just like, well, there's more RAM available. Actually, the cloud CPU speeds, as it turns out, are like not great. Really, it kind of becomes a function of how much RAM is available. And so, for things like that, there's a lot of really kind of clever things you can do. And again, it's all seamless, like you guys cut out earlier. Like in my DBT project, I just put the S3 path for where the files are located, load them across into my MotherDuck instance, and then run all the queries. And it's super fast. It's it's awesome. So, yeah.
Well, and I think I remember you commenting even like, because I think I quoted the blog in a LinkedIn post. It was looks like it was almost exactly 2 months ago, but I think it was George Fraser from Fivetran put but it was basically pointing out that most queries are small. Like,
yeah. I
think it was like between Snowflake and Redshift, and that like I'm reading it here. It says of queries that scan at least 1 megabyte, the median query scans about 100 megabytes.
Yep.
So, I mean, like in the 99th percentile is 300 gigabytes. So you see all these benchmarks on terabytes or petabytes of data or whatever they want to talk about. And like no one actually does that in real life.
Yeah, totally. That's like our kind of, we have this thesis. Jordan, our CEO, wrote this great blog post called Big Data is Dead. If you type Big Data is Dead, you'll find the post where he looked at that data as well. Some of the same stuff that George looked at. And yeah, the reality is that, when you do query data, you're not querying that much. Part of the story there is that when we kind of came into the big data era, let's say 2004-ish, the kind of underlying assumptions was you just needed to make all your software run across multiple computers at a time. And that's like kind of this notion of massively parallel processing that a bunch of things like Spark, for example, are excellent at, right? Really nice abstraction. But as it turns out, there's a lot of overhead to run systems that way. And so we're kind of like, returning back to the single node era with what we're doing at DuctDB. And part of that is just because, actually now the amount of compute and storage available to us has exceeded or will soon exceed our ability to create data. which is a crazy thing to say. I would not have believed it 10 years ago. But,
high school me buying a 256 megabyte flash drive for $150 does not believe that.
Yeah, correct. Like I remember like things like in 2005, it cost $2 a gigabyte for a memory, for a hard drive. Those things cost, it's a tenth of it's 1 cent per gigabyte now for a hard drive, right? Like it's insane. You can fit like in a spinning disk drive, there's 36 terabyte spinning disk drives, like a single drive. Like what? Like there it's insane how these things have scaled. And so really what that means is that single node is an insane benefit for us, right? Because we don't have all the coordination overhead with that to compete with. And, for better or for worse, machines or systems like Snowflake and Databricks, excellent databases, right? But they're kind of designed kind of in this notion of running against a bunch of nodes at a time. And so they have extra coordination expense that we just don't have.
So that's horizontal scaling versus vertical.
Yeah, we just scale up. We only scale up. You don't, and that's not exclusively true, but for the purpose of like kind of just a thought experiment, that's right. We're working on some scale out on read type stuff where you can just like spin up multiple nodes and read against the same database at once. That'll be out relatively soon, which is really cool. But yeah, the thing is single machines just getting bigger, and we'll just focus on making sure that our system scales up to the biggest possible nodes. And if we can do that, we believe that we can give you a faster experience, a better experience, and we can deliver it for cheaper. And that's really powerful.
So I'll just talk about what my hesitancy is. It's probably more ignorance than anything.
Sure. Just
with MotherDuck, say, versus Snowflake or Databricks. And It goes back to the driver question of like, how can I connect my BI tools to MotherDuck? Because again, Snowflake has excellent drivers and stuff like that. So just, what does that look like if I want to connect, Power BI obviously is probably one that you get often, but oil and gas, TIBCO, Spotfire is one which I'm sure they don't have a native connector for MotherDuck at this point. But
we're happy to build one. So we definitely recognize that like a big part of it is the ecosystem, right? So we have, for example, on ingest side, like native connection with Fivetran, for example. We just
good
upgraded
start.
Yeah, exactly. Good start.
and where does that land? So then I'm thinking like so y'all are hosting that in AWS or various cloud providers, and it's going to blob storage, I'm assuming, or
yes, but it's in MotherDuck's native kind of format, which is kind of a differential storage layer on top of the DuctDB format.
Okay.
So we get to take advantage of all the really nice things that DuctDB has, but then also take advantage of things like zero copy cloning by building a clever storage format. So it goes into the MotherDuck native format straight from Fivetran. We have an Airbyte connector as well. If you're in that world, there's a bunch. We have an ecosystems team that's very focused on building all of these out. Do we have everything yet? No. Are we continuing to build it out? Yes. Do we have a Power BI connector? Yes. One that we built, right? So we recognize that the interop is definitely a key part of that, and we're building that. This is actually a nice segue into kind of another thing we're thinking about, which is we've recently announced this project called PG DuctDB, which is running DuctDB inside of Postgres, and that can connect to MotherDuck as well. And so really what that means is anything that connect to Postgres can also connect to MotherDuck. Now it's very early; it's alpha software today, but we're continuing to work on that in partnership with some other folks. To
walk me through that real fast, because our app is on Postgres. This is why I'm asking. So
sure,
and I'm using Fivetran to move that to Snowflake currently.
Yeah, sure,
right. So walk me through. Just as a potential user of that.
Yeah, sure. So if you're on Postgres, there's multiple ways to do it. So there's really great. Again, this is kind of early innings here, but I'll just talk about it. So we've got PG DuctDB, which installs DuctDB inside of Postgres, and does a whole bunch of really really interesting things there. We're still working on things like reading Postgres indexes, for example. We don't read indexes when we read data from Postgres with PG DuctDB. It's very early. So be hesitant to advise you to run that on a production database today.
For sure.
But
like if I'm trying to do analytics on the Postgres data, right? So it's a social, think of it as a Reddit, right? But for the energy industry. So I've got all these it's a relational database, but there's lots of events that happen in said relational database. And then I need Google Analytics data with it and all this other shit,
Yeah. So the trick there is that because it has MotherDuck connected, you can actually very easily kind of send data over the wire to MotherDuck and then not break your production, use all of your resources on your prod server for analytics. You can just basically write the query. It'll go out to MotherDuck, and then return kind of the rows back to you in whatever your Postgres in your Postgres native, whatever format, so that you can kind of like not think about it. But there's a whole bunch of really, really cool stuff that team is working on, like being able to read directly from the native Postgres format very fast.
God, that's awesome.
It's not a foreign data wrapper, so it's not like a linked server like you would do like in a SQL server where it's like a separate server. There's really not predicate pushdown. No, we're trying to solve all that stuff. It's very hard. It's going to take a long time. The next thing is there's actually something called a PG scanner that's for DuctDB. So you can actually install it. It's a library. And you just type in like install PG scanner and then load it, I believe. And then you create a relationship to your Postgres database, and then you can query it with DuctDB kind of on a separate machine. So like if you're on your laptop and you want to query Postgres, you can use it just like you'd use the Postgres command line. So that's really cool because what it also lets you do is do things like create table as select again, and it'll pull the whole thing over across into DuctDB, and then you can do all your analytics in DuctDB queries, right? And you can do that with MotherDuck as well, send the data into MotherDuck. So those are kind of two easy options. Again, all the other things still work, Fivetran using Postgres to MotherDuck, things like that. There's an really interesting project that I've seen right now from one of the guys at LiveRamp that is called Universe SQL, and it's basically a DuctDB cache on top of Snowflake. So you can basically pull down like a thin layer of data from Snowflake, do a bunch of DuctDB stuff on it, and then run it back into Snowflake as an example. But there's a whole bunch of early stuff there. Core replication. I think there's a reason the reliable tools are the ones we know and love because those problems are really hard. And when you run into them, it feels like a waste of time. So it's very hard to kind of dedicate resources. I will say we've had a lot of success recently with estuary.dev as a kind of CDC replication partner from Postgres.
We had David on, a month or two ago, John?
Yeah.
Oh, cool. That's awesome. Yeah. So we've actually seen a lot of customers using that. And like, I remember I've done, I wouldn't say quite a bit, but I've done some SQL Server CDC and like probably 5 years ago. And it was so hard. So like, I think the abstractions have gotten tremendously better recently for those types of replications. So I think there's a bunch of options. I think the one that like I would recommend to people who have Postgres today is use the DuctDB PG scanner. And literally you can just read from it and just think about it as like a little analytics cache on Postgres. And you still have to do all the reads. Yeah, you still have to you still have the cost of reading the data, right? So but
you have that cost regardless, right?
It just means that your first read will be the same speed as if you're reading it from Postgres directly. The second, the thing is, once it's in the DuctDB format, then you get all the advantages of the DuctDB stuff, and you can just run it on the table there.
Right, but I'm not querying anything in Snowflake at that point either, right? Like all the analytics queries are happening in DuctDB, so I'm not getting charged from Snowflake.
Yeah, correct. Especially if you're doing stuff that's like, one thing I really like about DuctDB too is that like, there's a lot of stuff, especially like in the kind of more data sciencey workflows where you're not sure if it's going to work. And so like,
absolutely
running, being like, okay, I'm going to run this on Snowflake and I'm going to crank this up to like a 2XL and it's going to take 3 hours. You're like, do you want to do that? I'm like,
I
don't want to do that. But like, if I have a DuctDB kind of, set of queries or a Python script that takes 3 hours, like, first off, congrats. I don't think I've ever seen a query that takes that long. But like,
no kidding.
Second off, it's like, it doesn't cost you anything, which means like you can take bigger bets in terms of the things you're thinking about, because you're like, okay, if I can get this to work, then I can optimize it, and it's it's effectively free. And then there's always MotherDuck to kind of offload that too if you need to as well, right? And so I think that's like a really interesting pattern that like I think a lot of teams on the data side are like a little gun shy right now. Like there's a ton of hiring. Data scientist was like the sexiest job. Like that was written by HBR, right? Like
or Time magazine, one of the two.
Yeah. So like it's like so there's this big promise that like, oh man, we're like our businesses are going to be so much better, like it's going to rule, and it's like actually everything stayed exactly the same. It's like so now everyone's like, wait, we have this data team, we're not like, are we better off? What's the ROI of this thing? And I'm just like, okay, those are really hard. Like it's hard when you get into that situation, it's hard, right? And maybe you hired the wrong people. Maybe it was just like the expectations were wrong, whatever. But like, if I can say, hey, I can bring in this tool and I can actually de-risk our entire team because we can run it on either a small server or our laptops. And then I can, take some really big bets and see if these things work. I think that's really compelling because a lot of people have kind of been burned by their Snowflake bills just going up every month. Their business is like they don't really have a good sense on like are things improving, what's happening here. And so I think there's something there. There's something to that too.
I think the thing there, especially with our industry, we've got a lot of engineers, right? We're one of the most technical workforces in the world. And the engineers are the SMEs on the data, but typically IT gets involved and, kind of cuts them off from access to that data. And so there's the whole, in energy, everything is thought about from a risk perspective first, because, instead of the app not loading, there's a catastrophic failure, people die, there's Macondo, there's all kinds of bad things that can happen, which is good. But the flip side of that is it disincentivizes people to do new things, take risks and all of that. And so just imagine this world where it's like, hey, SMEs, you can have this abstracted layer or access to this layer to do your analytics and to test all kinds of different stuff on, and it's not costing us money in Snowflake every time we touch it.
And then I think this even brings up a pattern that I think maybe I thought about it, and I think I maybe saw you talk about it maybe even a year or two ago, Jacob, was like now with DuctDB and DBT and be able to run these things like kind of locally, you can really you can do an ELTL. Even if you dared, if you wanted that cloud thing to serve it out, like, even just load it into Snowflake so that it's like a nice fast way for people to interact with that final, gold layer if you're doing a medallion thing. But why can't I just store all this stuff, even run it on a local server again, because this could go single node and I don't need to run my DBT like on those cloud servers all the time, or on Snowflake. I mean, like you could run these transformation things, and now we're coming full circle then, right? Back to
absolutely. We're definitely coming full circle. Yes. Yeah. I mean, I think one thing that I love about it too is that like it really brings tools that previously were like, like you're talking about oil and gas, SMEs, engineers and geologists and stuff like that, right? Like, what if they could have all that power? Just like, like they probably are using Python because Pandas is very convenient. It's like, well, what if we can like supercharge that? Like literally 100 times faster than Pandas is DuctDB. Like,
and you can read your Pandas data frames from DuctDB too. I want people to know that too.
Yeah, you can. It's amazing. So I'll send you guys some stuff. So actually, I've been working on yesterday. What I was working on actually is I'm working on some like basic replication patterns. And because SQL Server is the database I know best, I'm actually starting with SQL Server. So I wrote something yesterday where I spun up SQL Server on my Mac. This is where I discovered it's a slightly different dialect, and loaded AdventureWorks into it, right? Which I'm sure you guys have seen. And then wrote a couple of lines of Python, and now that data is in MotherDuck, right? And so you just can kind of use like the ODBC, which is officially supported by Microsoft, the ODBC library, and so you can just return that as a data frame, and then load that straight in, load that into MotherDuck. So, like that's how easy it is today. Like, I'm trying to like not be too like say, oh yeah, it's just so easy, but like also for those of you that were here like 10 years ago, you'd know how hard this was. Right? Like
you said, you're doing it on like a Unix based system. Like I've wrestled with all the different ODBC drivers for SQL Server on there, and like having to screw or dick with all that. I mean, like, it's just insane.
Yeah, like I actually was surprised. Like, it worked basically the first time. I think that's just because
one thing that's crazy too that I think we learned on one of our podcasts. We had this guy John Archer on, who's from Red Hat. They've got an office actually right across the street from where John and them are. They have this cool innovation center with Chevron or whatever. But apparently SQL Server runs faster on Red Hat than it does on Windows.
I'm not surprised. I mean, like, there's lots of crazy stuff that you can do, and there's a fair amount of overhead, I think, in the Windows side, but yeah, it's definitely, so I'm definitely, part of my focus over the next few months is going to be, writing about, hey, here's all the ways you can, take your BI load and lift bits and pieces of it into MotherDuck, and here's how you can use DuctDB, because that's very near and dear to my heart. I want to empower analysts broadly. That's why I came to MotherDuck, was like, I know I'm a great analyst, but like, how do I make, 100,000 or more, people have that power. And that was part of what inspired me to join. So, we would be remiss if we didn't talk about AI features, by the way, which we kind of like, we quickly glossed over, but a couple things we're building that are really cool from a MotherDuck perspective, is we are making it really easy to use, embeddings, and so like vectors and large language models inside of MotherDuck. And so there's kind of two ways we're thinking about that. The first way is like as a query interface. So we've actually trained our own model to where you can ask it questions about your data and it will return SQL and execute it for you. And so that's actually available on Hugging Face. So it's pretty cool. And we use that in our own product as well. So like if you write a SQL query and it doesn't work right, we make a suggestion on like, hey, here's how you can fix it. And where it really helps, honestly, is like
that's
things
specific
like
to the DuctDB
dialect. Yeah, correct. And we're training
How
another
much-
one kind of right now.
So, like Bobby mentioned, well, I don't know on which recording, but at one point Bobby mentioned I play with LLMs a lot.
Yeah.
So walk me through that, like setting that up, right? So I've got a SQL table. I want to be able to query it in natural language. I install DuctDB, or I set up my DuctDB instance, pull my table into DuctDB. Do I need to map anything? Like how granular do we have to get on that? I'm very, very, very interested in this problem specifically because it's a universal problem regardless of the industry you're in. Everybody that you talk to, at least at a management level, that's remotely familiar with LLMs, the first thing they say is, "Oh, I want to be able to query, I want to figure out why my IoT data is so bad, or what asset is failing, or what the outliers are, and all this stuff." And I'm like, well, you really need ML, like true ML, not language models, but the language model piece where it's like, hey, I use language models to write SQL all the time because I never learned SQL, and I don't know if I will have to because the language model can do it for me now.
Yeah, sure.
And so it's like the language models know SQL pretty damn well. It's just you have to make sure they understand, the schema and the structure and the relationships and all of that. And so I think whoever figures this out is going to set themselves up incredibly well in the future because everyone has this question and problem.
Sure.
So just briefly kind of walk me through what that looks like. We don't have to get into a ton of details about it, but
yeah, we have a few interfaces for that. Basically, we've set them up we've kind of set them up as functions you can call. So we have one that I just linked that's called prompt SQL. And so you can actually give it a prompt and then you tell it what tables you want to look at also. You don't have to give it tables. If you don't give it tables, it'll just use the database you're currently in context of to answer that question.
That's awesome.
So like, it's pretty good. Obviously, like the quality of your column names will really kind of make it. If you've got like a set of gold tables, it's actually incredibly good against like a gold set of tables. If you can kind of scope it to like, hey, like you only care about these 10 tables. We got a fact table, we got a dim table, we got a whatever. It actually works really, really well. And you can also set it to just return the query to you so you can see the query. So like one workflow we've seen is it'll just be like, someone will be like, hey, I'm thinking about this problem. Here's what the query looks like. Like, hey, business analyst or data analyst, is this the right query? And instead of the conversation starting with like, hey, I want to see this thing. Someone starts with a query and now we're all speaking the same language, right?
Yeah.
Because if it's too much for the data analyst to confirm, they can work up the chain, all the way, to a data scientist, to a data engineer, to a software engineer, if they need to, right? And that's actually very powerful. Being able to start there. We gave a really cool demo at PyData last week, kind of about this topic, where we pulled a bunch of data down and then ran it locally and then run these things. So it's as simple as connecting to MotherDuck, and then you have availability to these functions, and you can do that in the command line. So you can just in the command line do or in Python you can just do DuctDB and then MD:, and now you're connected to MotherDuck, and all of these functions are available to you.
And then,
so that's the
of
first
course,
thing.
because it's lightweight, I can push my language models and the associated data with them to the edge and do it all there.
Yeah,
and not have to.
The model. Let me think about this. You could use our model on the edge, yes, but if you're trying to use the functions we've built into DuctDB, you would need an internet connection.
Okay, because I gotcha. They're in the.
Because and so the other thing we're doing is we have this prompt function you can use that's a scalar function, so you can use it. So you can do like select prompt whatever, and you pass a prompt into it from some table, and so you can pass like values from that column. Like I'll give you a practical example. So like my buddy sent me like a wine list. He's like, "Hey, I'm ordering some wine. Do you want to like add a couple things to it?" I'm like, "Sure." I don't know a lot about wine, but sure. And so I just had like the name of the bottle and like the region and the year and the price. And I'm like, okay, well, I don't know a lot about these, but what I can do is I can pass the name and the region and the year to a prompt and say, hey, write a description of this wine. And then because it knows, hey, this region produces this type of wine, because it knows this year was a good year, because it knows it knows a few things about this producer, it can kind of knit together a pretty good description of the wine. And then I can say, oh, well, now I have a description. Yeah. I can actually make a decision that's sort of educated on this. And it worked pretty well, like surprisingly well.
Wow, that's cool.
So, but yeah, that's all using SQL. So we have and what's cool about that is, so we do all the parallelization behind you. So we run about 256 queries at a time when you are prompting it. So we're just running that up against like the chat GPT kind of APIs. But we're working on broadening that, so you can maybe bring your own token or choose a different model or all that stuff. But that stuff is like required to be internet connected to make it work.
Yeah.
But really, what we're seeing is that folks are really liking it for things like I was talking about, like writing a product description, but also like it can do structured text. So you can say like return an answer that like matches this structure, right? So like maybe if you're doing some data profiling, and again, like all of this stuff, what it does is it accelerates all of the things that like ML researchers have been talking about for a long time, which is like, hey, like this data, like this stuff is like only 80% right. So you can't just use it. Like you have to think about all, like the good news is there's lots of really good writing out there by these researchers. That's like, here's how you judge if a prompt function is good, and here's how you improve it and things like that. And so now you can push all that stuff down instead of being like really, really expensive ML researchers. You can have like data scientists or data analysts, doing that same type of loop, which is really powerful, again, especially for like unstructured data that you're just trying to understand, like reason about and group and things like that, right? You were just talking about like Reddit type comments, right? Like, maybe extracting sentiment or saying, hey, like, or adding topics to them, so that you can sort them later. Like there's probably a handful of things like that where like it makes a lot of sense to use LLMs to run that if you can do it at the right price and with the high enough accuracy. So
no, that's I'm a big as someone who used to have to come up with all the labels for the data on our CRMs and ERP systems historically. I'm all about feeding a prompt with the list that I want, or letting the prompt come up with them from the data, which is how it really should be done. No, I love these things for a lot of the data stuff, whether it's extraction or labeling, and like you can easily see where it's like, hey, it's gonna do it the same way every time, hopefully, depending on what your prompt and temperature are and stuff. But even then, it's like as long as it's consistently doing it, it's gonna be more consistent than a human, because it doesn't get tired, and it doesn't have a 5-year-old that comes and wakes them up at 3 a.m, or like it's just
relatable.
It's just the normal stuff. But I mean, you could easily see a world though where you guys. I mean, I'm thinking of it for the oil field out of the gate, right? Like, our enterprise clients are going to want to be able to use our energy language model or their energy language model from their phone. The field guys want to be able to use it in the field, and so like, hey, we use a 5.3 model, or one of the smaller lightweight open source ones that gets trained on on the text to SQL, then you can deploy it with DuctDB and MotherDuck right there on the edge device. And so that's completely secure. That's a really, I think ultimately for a lot of the enterprise, at least field level stuff, that's going to be what a lot of architectures end up kind of looking like.
I totally agree. I'm seeing some of the same, especially in like more secure, like air gapped environments where they're like, they've got like a SQL server that's 20 years old that someone set up and, doing any analytics on it, maybe a historian or some SCADA or whatever. It's like, can we just please get DuctDB in here so that we can like actually analyze our data? And as it turns out, that's not necessarily a MotherDuck use case, but certainly one that I'm seeing and have been talking to people about because it's super interesting.
Well, you also, like at some point, all the cloud credits run out and people actually have to start paying for their compute. And they're going to be pissed off when they're like, oh shit, I use a lot of chat GPT credits and they're expensive because of course those will only get more expensive somehow over time.
Yeah, totally.
But
I know you're getting close on time. The only other thing I want to talk about that people should be aware of, I think, with DuctDB is just how that they've pushed forward, I think, some like SQL syntax or functionality, group by all, or even, again, some of this will trigger a lot of people, whether you should do group by all even, or even just, allowing a trailing comma. But I mean, and I think there's more to it than that even, but I mean, can you talk about just a couple of those, or even maybe your favorite of those? Or
so there's a couple that I really like. So one of them is you can just skip select star. So you can just type in from table and it'll return the table. Another one is...
I already like that. I like that a lot.
So it also has this notion of select star exclude. So you can do select star and then exclude, and then you can type in the columns you just don't want to return. Right. So a lot of times it's like, okay, like I want to return, like get this list of table, but I don't want this ID. I want an ID from somewhere else or whatever. And so you just can ignore that. There's a few other ones, like there's some really interesting stuff. Like it has a bunch of like text matching functions. This isn't really about like SQL syntax per se, but it has things like Levenstein distance and stuff like that. So like when you're doing entity resolution, it's very fast and easy to do with native functions.
Is that almost like fuzzy matching kind of stuff?
Yeah, like fuzzy matching kind of stuff. Yeah, and like ranking for sure. It has, and I'll talk about one other one too. So it has this function. So like when you're looking for the latest record of some row, right? Where you use like qualify or a row number and order your data set, right? So when you use those types of functions today, it requires you to order the entire data set. And so DuctDB has added this function called argmax and argmin. And so what it lets you do is actually pass in a row and then sort it on some arbitrary kind of dimension. And so what that means is it can, instead of sorting the entire data set, what it can do is only sort that segment. And then also that means you can break that up into pieces and run them in parallel. And so you see for some scenarios where instead of using qualify, if you use like argmax instead, you can see like 10x or 100x improvement in query speed. And like that's a really fun one where you have like an append only database with a bunch of versions of rows where you can just select only the latest version of each one using like a timestamp. And it is insanely fast and practical. For stuff like that. You wouldn't kind of like the documentation is just like, we have this function called argmax.
Right.
It's like, it's here. And you're like, okay, like, what does that mean? And then like you see someone use it and you're like, oh, that's how
that makes perfect sense. Yeah.
Yeah.
And that's really fast.
Yeah. So there's some really cool stuff like that. They're definitely, so they're definitely doing some cool stuff. That uses this algorithm called radix sort, which is slightly different than traditional sorting. So anyways, it's a little faster. Actually, it's a lot faster if you have a data structured a certain way. So very fun.
Awesome. John, want me to get real quick into speed round and then we'll wrap it up?
Yes. What is your favorite LLM for coding currently?
That's a good question. I am a GitHub or a VS Code user, so I use whatever the GitHub Copilot stuff is. They do have Claude in there now too. It works pretty well. So I'm not really tied to one. I do pay for ChatGPT personally, and I use it all the time too.
Yeah. Nice. You should check out Cursor if you haven't played with Cursor yet.
Okay.
the only reason I bring it up, it's a VS Code fork, so it's very familiar. But there's just some of the easy things that they have where it's like copy a piece of code, add it to the chat, add my repo, all the files, the config, everything to it. It writes the code, and then I click a button and it applies the code, and I don't have to copy and paste anything. It's incredibly nice. But
noted.
I've been using Claude a lot recently as well, and I think the hype is real with the latest update as far as it being better than ChatGPT with coding.
Got it.
What's your favorite non-DuctDB database?
I mean, it's definitely SQL Server. Like, I think I definitely, I have a little bit of, it's probably Stockholm syndrome, to be honest with you. But like, the thing is, the most important thing that I learned about SQL Server is to like be able to understand how the query planner works. Yeah. And for better or for worse, it's now second nature. And so that means that I can see something and optimize it, kind of mentally very quickly. And it's served me very well, although I don't have to activate that part of my brain too much anymore. But partitioning and set up your partitions, set up your indexes, and use temp tables can get really far.
Nice. JK?
Favorite video or board game?
Oh, that's a good question. So there's a game that came out probably probably 8 years ago called Rocket League. Play a little bit of that.
Oh man, I love Rocket League.
So big Rocket League fan.
It's soccer with RC cars for those who aren't familiar. Yeah. It is so much fun.
Yeah, it's a lot of fun. Scratches a competitive itch for sure.
It's also really fun to get humbled by a 12-year-old.
Yeah,
it's a good way to get it.
Yeah, but I have kids now too, so we'll play like Mario Kart and stuff too. So a lot of fun. Yeah.
All right, and I'll stick with my food theme. So if we took a trip up to Seattle, where do we need to go?
Yeah, there's a few things that I think are excellent in Seattle. Really good like teriyaki. Really good seafood like sushi. And there's the classic, which is there's a burger place called Dick's that is kind of like a local legend. So
very nice.
That would be the three. Yeah.
Sweet. Awesome. All right, last one, most importantly, and it goes to both of you. Who's going to win the fight tonight? Since we've been talking sports in and out through this whole thing, Tyson or Jake Paul?
I mean, I think I'll go conservatively here. I think the odds markets, the betting markets seem to favor Jake Paul, so I'll go conservatively.
The guy that's 30 years younger.
Yeah, exactly.
Yeah, I'll go Mike Tyson, and I just think he can't turn it off. I imagine they probably have how this fight's going to go planned out right now, and it doesn't matter how it's planned out because Mike Tyson's going to get in the ring, and if he doesn't bite his ear off, he's going to knock him out. Like,
Yeah. I think if it goes more than four rounds, I think Paul will win. But if he doesn't get knocked out by Tyson, I don't know. Yeah. That dude still looks like he can murder people. So
for sure. I would not want to get in the ring.
No, not at all.
Yeah. Cool.
Well, awesome, man. Awesome. Well, thanks so much for joining us. And where can people find you, or how can they reach out to you?
Yeah, absolutely. So I'm on LinkedIn. You can find me, Jacob Matson at MotherDuck. I think my LinkedIn URL is just Jacob Matson, and then also on X/Twitter at MatsonJ. Feel free to harass me there. I'm happy to chat, DuctDB or otherwise. So yeah.
Beautiful. Well, thanks again. And Johnny, anything else?
No, make sure you guys subscribe. Like I said, 75% of you are not subscribed. So go click the button wherever it may be. Appreciate it, guys. Thanks, Jacob.